Okay, so today we're going to go over the extra credit for Krista's research. Um, my name is Ethan King, and this is the Exam 2 review. And today we're going to be going over Huffman trees. So what are Huffman trees? Huffman trees are used for file compression and it allows us to take a string of characters and compress it into a smaller space than if we were to just represent it using, let's just say, the ASCII values. What it does is it's going to create a shorter path from this root node for things that are more frequent. So if we look at like this example here, we've got these fours and this seven are higher up in this tree than these ones that only appear once. And then for the purposes of this class and exam, going to the left, we're going to count as that's going to be a 0 when we're decoding and encoding. And going to the right is going to be a 1, but in the real world, it can go either direction. So, all right, how do we create a Huffman tree? So we're going to use this example phrase of silently listening. So our first step is going to be to create a frequency table like this one shown here. And what this does is it's going to take the characters that we have and however many times it appears is how many times it's going to be in this frequency chart. So for S, for example, we've got 1 and 2 S's, so 2 is going to be its frequency here. And so you just do that for all of the characters, and then your next step is you're going to want to order them in an array style fashion in the order that they appear. So here we've got all of the ones, all the twos, and all the threes. Okay, so we've got all of our characters, we've got how frequently they appear. Now, how do we create the Huffman tree? Well, we're going to take the smallest two nodes, which in this case is G and Y, and we're going to take the sum of their frequencies, and then that's going to be its root node, and then we're going to use that to create its children. And then we're going to repeat this over and over again. But first what we need to do is we need to reinsert our tree back into our array so that we have all of them in our same tree. So now when we perform the next step, this space character and then this 2 tree will be our next smallest one. So then we'll have a 2 and then we'll have a 1, then a 3, and then it'll branch down. And so we repeat this over and over again until we've got all of our trees inserted into it. So this is how, using the array that was given on some of the previous slides, this is the Huffman tree from this example. Here we can come down and see some of the examples we did where we have the G and the Y, goes to the 2, goes to the 3, and the space, and the 1. Its next one going back. Well, I think I have these out of order a little bit, but you could, it doesn't matter so long as they're the same frequency, but here we've got it going to the S and the 2, and they create a 5, and then that would have been reinserted back in. Actually, no, I don't have it out of order because the 3 would have gone into here. And then E and T would come to this 4, and it would create its own and then be reinserted. So when we're decoding a Huffman tree, we are going to basically be taking path for each character. So let's do our G, for example. So if we're saying right is 1 and then left is 0, G's code would then be 1, 0, 1, 1, 0. And you can do this to get a code for each of the characters within a tree. And so this is what it would look like for our Huffman tree that we have, what the codes are for each of our characters. And as you can see, we had I and E and T, which were some of the more frequent ones. They have a shorter code compared to like G and Y, which only appear once, which have a longer code. So if we're given a binary code and we're asked to decode it using a Huffman tree, we're going to need to follow our path until we hit a leaf. Because in a Huffman tree, every leaf is going to be our character. It's going to be our data that we're storing, and we're using it to compress. So with this example, we've got the code of 101100100011. So to decode this, what we're going to do is we're going to follow its path. So for this first character, we don't know what it is. We're going to go 1, 0, 1, 1, 0, and we've hit a leaf. So that lets us know, okay, so this is our first character. So our first character is G. And I believe that we ended up here. So for our second character, we need to go 0, 1, 0, which is going to give us E. And then for our last one, we're going to go 0, 1, 1, which is going to give us T. So that completely putting them all together gives us get as our encoded word. Thank you so much for watching. I hope that this helped for anybody, hope this helped for the research, and I hope this helps for any exams. Thank you.